Now let's see Poisson. Poisson also brings in the funda of time in here. Poisson distribution. The French name is a bit difficult. We call it Poisson. Poisson. It's okay. So what does it do? Poisson distribution. It expresses the probability of a given event occurring in a fixed interval of time. So it is used to model the probability of an event which is happening in a fixed interval of time. It is used to model an event probability. They are all talking about probability distribution. So probability of an event, okay, probability of a given number of events, count given number of events occurring in a fixed interval of time. Okay, this is what we want to find, so that if some event is happening at a fixed rate, okay, and we want to find that how many events will happen in a given interval, so what is the probability of that, then we use what is called Poisson distribution. So there are some other parameters associated with this. So given there are some parameters. What is given? So given that some conditions, events occur with a known constant rate, so they occur at a constant rate. Events occur at a constant rate, okay, and then these are the assumptions, okay, and then the second one is that is the next event is independent of the last event, that the occurrence of next event is independent, okay, it is independent of the time of last event, time since last event. So there is no such, we just know the average constant, the constant, okay, events occur at the known constant rate, means we know the average time, but there is nothing like that it will happen at a fixed interval, okay. If we know that if this has happened, then after this time this will happen, we don't know that is fixed, but we know that within a given window these many happen. I'll give you an example, then you will understand. Let me give you the parameters first, and then I will give you an example which will make it amply clear. So what are the parameters for this? So we have this parameter lambda, which is called which gives us the expected number of events that we expect events per interval, whatever is the interval, minutes, hours, whatever is. And then we have the other thing is probability k events, okay. Then probability, if we have that we know that lambda events happen in a particular event, then probability of k events happening, okay, k events in the same interval, probability of occurrence of k events in the same interval. So we know the average rate, and now we want to find some other count of events that will happen in the same interval. What is the probability of that? That is given by a formula, so that we have the PMF for that. So the PMF for this is lambda to the power k, and we have E is exponential minus lambda by k factorial. This is factorial. So if an event follows these properties, then we can easily find the probability of k events. So this is for this is equal to P for x is equal to k. That is expectation. What will be the probability for k such events? If we know that lambda events will happen in an interval, what is the probability of k such events happen in the same interval? So this is what it gives me. So let me give you a quick example. So generally this is used to model, say for example, if you want to model the number of customers that will visit a service center in an hour. Okay, so number of customers that will visit a service center, say that is any mobile company service center, in an hour. So you want to model this, Poisson distribution can be used, or a Poisson process also it's called. Okay, for example, if you want to see, like if we know that on an average there are lambda clicks happening on a website, then we want to find out the probability of k clicks in an hour, then this it's a similar problem and that can be used. Okay, number of website clicks in a given time period. To model such things, such processes, we can use Poisson process. So let's solve a problem to understand this better. So I'll give you a question, we'll solve it together. Okay, so for example, a company receives, so there is a customer. Okay, so there's a company that receives 5 customer emails per hour. Now we have to find the probability, that what is the probability that the company will receive exactly 3 emails in that hour. Okay, in the next hour. So on an average it receives 5. So what is the probability that in the next hour it will receive 3 emails? So let me write in the question for you. A company receives on an average, okay, 5 customer emails. 5 customer emails per hour. Okay, make it full stop. What is the probability? What is the probability? Probability. What is the probability that exactly 3 emails will be received in next hour? So we know the constant rate now, lambda. So we want to calculate, that is 5. So I hope this looks like a 5. Sorry, this looks like a 5, and we want to find 3. So what all things are given here? Solution. Lambda is equal to 5, that is expected number of emails per hour, and k here is 3. We want to find 3 emails in next 1 hour. We want to find this. So what is the probability? Probability of x is equal to k is given by lambda to the power k e to the power minus lambda by k factorial. Here k is equal to 3, and let's put it. So we want to find p of x is equal to 3 is equal to lambda is 5 to the power 3 into e to the power minus 5 by 3 factorial. This is the value. This is equal to 125 into e to the power minus 5 by 6. So let's see what is the, let's do a quick calculation. So we have 125 into e cap minus 5, okay, and this whole thing should be divided by 3 factorial, that is 6. So this comes out to be 14.037, so it will be like 14.04, sorry, 0.1404. So this is the probability of getting exactly 3 emails. If we talk in percentage, that would be around 14%. Okay, I hope Poisson distribution is clear.